closer to each other. I'll explain. Right? Then a nail is there. To the nail we connect the sonometer wire. The sonometer wire goes over the two bridges. After that, sonometer wire goes over a smooth pulley. There is a smooth pulley. The sonometer wire goes over the smooth pulley. To the end of this sonometer wire, we connect a known mass. Please always use the letter capital M, because I'm going to use simple M in this practical for another thing, right? So mass is capital M kilogram. Then weight of this known mass acting downward as capital Mg Newton. The tension in the string is T Newton. Tension in the string is T Newton. So this is the very basic arrangement of a sonometer. In this practical, what is the only change that we did? The only change that we have done is we have kept the two bridges very closer to each other. After that, we have placed a small piece of wire. This is English letter V. Inverted mean up and down changed. Then we placed an inverted V shape, very small piece of paper. Lanka පත්‍රයේ දෙකට නමලා තියෙනවා කියලා නෙමෙයි ඔය කිව්වේ. That's why I said a very small piece of paper. Right? Okay dear. මොකද සමහර ළමයි හිතන්නේ ඉරිද ලංකාදීපේ කියලා දෙකට නමලා මෙතනින් තියෙනවා කියලා නෑ. එහෙම නෙමෙයි. Is it clear? Right. So what are the things we did? Let me explain everything from the very beginning. Babbos, look at what. Let me explain everything from the very beginning. In this practical, we want to find the frequency of a tuning fork. Frequency of a tuning fork means these vibrating arms, when you take the stem, when you hit the arms on a solid object, it's better to use a rubber. Special pad is there. On it we hit. මේක උඹලා අරන් ගිහලා ගහන්න එපා කොන්ක්‍රීට් එක ආම්ස් එක කඩලා යනවා. දැන් අපිත් තියෙනවා වයිබ්‍රේට් ලැබ් ස්කූල් ලැබ් එකේ අපිත් තියෙනවා ටියුනින් ෆෝක්. එක අතක් නැහැ. ගියරුද ගිහලා ප්‍රැක්ටිකල් කරලා. එහෙම නෙමෙයි. Don't break the things. Right. So take the stem, hold and slightly hit on a solid object. Then the vibrating arms start to vibrate like this. Okay. Then we place the stem on the tuning fork. Which part of the tuning fork that you placed on the sounding box, dear? The stem. Which part of the tuning fork that you placed on the sounding box, dear? The stem. It is asked in the exam. Exam. එතකොට ලියනවා teacher go loading තියෙනවා කියලා. Right. So where should you place the stem of the tuning fork, dear? On the sounding box. How did we start the practical? We kept the two bridges very closer to each other. Why do we keep the two bridges very closer to each other? I'll explain within next 2 minutes. After that, we take Sunday Observer newspaper and bend it into the English letter V and placed on the wire. No, we take a very small piece of paper. Right? Lightweight, very small piece of paper and placed the paper on the middle of the sonometer wire. Why is that? I'll explain within next 2 minutes. Got it? So what are the 3 points that we have written so far? Let me read the 3 points one more time. We have written a note about 7 lines. Let me read. Number 1, a sonometer is used for this practical. A sonometer is used for this practical. Number 2, initially the two bridges are kept very closer to each other. Then navalangin tibbalo. Initially the two bridges are kept very closer to each other. Number 3, a very small piece of paper in the shape of inverted V letter is kept on the middle of the sonometer wire. In the shape of inverted V letter is kept on the middle of the sonometer wire. Please underline the word middle. Middle of the sonometer wire. Then examiner asks, why do you keep it on the middle? So I'll explain all these things. What are the three things I want to explain? Why the two bridges kept very close to each other. Why a piece of paper is placed on the middle of the wire. Right? Why do you keep stem on the sounding box? Why didn't you keep the tuning fork somewhere else? So those are things I'm going to explain. Right. Number 4. Number 4. I have written 1, 2, 3. Let's write number 4. The stem of a vibrated tuning fork is placed on the sounding box. The stem of a vibrated tuning fork is placed on the sounding box. The stem of a vibrated tuning fork is placed on the sounding box. Right? Star point and right. Star point and right. Star point and right. Then the vibrations of the tuning fork. Then the vibrations of the tuning fork are spreaded. Then the vibrations of the tuning fork are spreaded. Spreaded. Within brackets, transmitted. Then the vibrations of the tuning fork are spreaded. Within brackets, transmitted to the sonometer wire. Transmitted to the sonometer wire. Are transmitted to the sonometer wire through the sounding box and the bridges. Are transmitted to the sonometer wire through the bridges and the sounding box, or through the sounding box and the bridges. Through the sounding box and the bridges. Okay, dear? So, look at board. These arms are vibrating. Those vibrations are transmitted to the sonometer wire through the bridges and the sounding box. So, in the exam, it's not necessary, but here, please use some dotted lines and indicate that vibrations are transmitted to the sonometer wire. Use some dotted lines and show it. Next star point. So we have placed the stem of a vibrated tuning fork. The vibrations are transmitted to the sonometer wire. Next star point. Once the vibrations are transmitted to the sonometer wire, once the vibrations are transmitted to the sonometer wire, two transverse waves are formed on the wire. Two transverse waves are formed on the wire as shown in the following figure. Once the vibrations are transmitted to the wire, two transverse waves are formed on the wire as shown in the following figure. As shown in the following figure. Right, look at board here. Now I draw bridges little bit, keeping a little distance between them. Otherwise, it will be difficult to draw, right? So I keep a small gap between the two bridges. Otherwise, it will be difficult for me to draw, right? So once this is the bridge A, this is bridge B. A is said to be fixed bridge, B is said to be movable bridge. Once the vibrations reaches to this wire, one transverse wave is formed and another transverse wave is formed on the two bridges like this. The first wave travel in right hand side, the other wave travel into left hand side. Okay, dear? Draw this figure. Draw this figure. So I have clearly explained what the transverse waves are. Please read my theory note. Draw this figure. අපේ online බබුන්ට මේක ටිකක් ලොකු කරලා පෙන්නන්නකෝ. Next star point. Next star point. As both transverse waves are generated by the same tuning fork. As both transverse waves are generated by the same tuning fork. As both transverse waves are generated by the same tuning fork, comma, both transverse waves are identical. As both transverse waves are generated by the same tuning fork, comma, both transverse waves are identical. They are same, similar, equivalent. Why? Because they are generated by the same vibrating arms. Got it? Next star point. Therefore, two identical waves are traveling along the sonometer wire. Therefore, two identical waves are traveling along the sonometer wire into the opposite direction. Therefore, two identical waves are traveling along the sonometer wire into the opposite directions. Right. Then what should happen? When two identical waves travel along the same path into the opposite directions, they should combine together and a stationary wave should be formed. What's it here? When two identical transverse waves travel along the same path into the opposite directions, they should combine together and a stationary wave is produced. I have clearly explained everything about stationary waves. Please read the theory note. If you are not in the class, please send me a message to the Zoom chat or send me a WhatsApp message. I'll give you the recordings. Got it, dear? Now, two identical waves traveling along the same sonometer wire into the opposite directions. Therefore, stationary wave must be formed. But a stationary wave is not formed on the wire. Why is that? Stationary wave is not formed on the wire. Why is that? Because this space, this space, the length of the wire is very small. The transverse waves are in between A and B bridges. Length of the wire between A and B bridges very small. That length is not even enough to make at least that length is not enough for a single loop. Do you remember what a loop is? Read the theory note. So as we have started the practical with the smallest length of the sonometer wire, right? Even a stationary wave is going to be formed. A stationary wave is not formed. Let's write it and I'll tell you the reasons next. Next point. Therefore, a stationary wave is going to be formed. Therefore, a stationary wave is going to be formed on the sonometer wire. Therefore, a stationary wave is going to be formed on the sonometer wire. Same line, same point. But the initial length of the wire is very small. Therefore, even a single loop is not formed on the wire. A stationary wave is going to formed on the wire, full stop. But the initial length of the wire is very small. Therefore, even a single loop is not formed on the wire.